Having a good understanding of the principles and processes of prokaryotic translation, let's see how the process differs in eukaryotes. Recall that eukaryotic mRNA is modified to include a 5' cap and a 3' poly-A tail, as shown in the figure below. For chain initiation in eukaryotes, there are 13 more initiation factors, clearly a more complex system. To designate a eukaryotic initiation factor, we precede the label with a lowercase e. The first step in this process is the assembly of the 43S pre-initiation complex, shown below. Factors EIF1A and EIF3 are bound to the 40S small subunit. The initiator tRNA is delivered to the 40S subunit by EIF2 bound to GTP. Note that in eukaryotic systems, the first amino acid is an unmodified methionine. In step 2, the mRNA is recruited to the ribosome. The 5' cap serves to orient the ribosome to the correct AUG start codon by a scanning mechanism, driven by ATP hydrolysis. Note the different order in this system. In prokaryotes, the mRNA binds to the rRNA of the small subunit before the initiator tRNA binds. In eukaryotes, the mRNA binds after the initiator tRNA. In step 3, you will note the similarity to the prokaryotic system. The large 60S subunit binds to form the 80S complex with concomitant GTP hydrolysis and release of initiation factors. Another distinction in the eukaryotic system is the formation of the cap complex. EIF4E is the cap binding protein, which is also bound to EIF4G. The poly-A binding protein, PAB1P, binds to the poly-A tail and links it to EIF4G, as shown in the figure below. This complex then looks downstream for the first AUG codon. Note that the assembly of the initiation complex in prokaryotes was dependent on binding to the ribosome binding site in order for proper positioning. In eukaryotes, this is accomplished by formation of the cap complex.